word problems in slope-intercept form. So we may be writing an equation from a graph or from two ordered pairs. We also might be writing an equation from a word problem. So an English situation, something that's really a story that's happening, and we want to write an equation to reflect that story. So let's take one particular situation here. We have this graph, and this graph shows the distance remaining to complete a tunnel. So we're digging a tunnel here, and this is showing that as time is passing in months, how many feet they have left to finish that particular tunnel. So our first question here is to write an equation that represents the situation. Again, we're going to do the same two things as if we have a graph or ordered pairs, which we do have. This is just a real world situation. We're going to start by finding the slope, and then we're going to finish up by finding the y-intercept. So to find the slope, I'm going to do the same thing I've been doing. I'm going to take my two ordered pairs, I'm going to use my slope formula, and I'm going to find my slope. In this case, it's a negative 500, which totally makes sense because this is a negative line. So I have a negative 500 slope. I'm also going to find the y-intercept. So my y-intercept here is 0, 3,500. It's right there on the graph on my y-axis. It's also in this ordered pair. Remember, our ordered pair for the y-intercept is going to have a 0 where the x is. So the y value is a number, the x value is a 0. So there's my y-intercept. So my equation looks like y equals negative 500x plus 3,500. So there's my equation. Second question, interpret the slope. So the slope here is telling us that the distance remaining is decreasing, and it's decreasing. We need a label on this. We need a unit because it's a rate, and remember our rate is always y over x, just like our slope. Our rate and our slope represent the same thing depending on what we're talking about. So y over x, so it's feet over months. So this is telling us that the distance remaining decreases. It's decreasing because it's a negative. It decreases by 500 feet per month. Remember, our label on our rate is always y over x, just like our slope. So feet per month. If we talked about what our y-intercept means, remember our y-intercept always talks about the beginning, kind of the start of our story. So at the start of our story, this tunnel is going to be 3,500 feet. That's how many feet they need to dig to complete this tunnel. Maybe it's not the whole tunnel, but that's how many they have left to do in this particular project. So they're starting with 3,500 feet to finish this tunnel, and the amount of feet that they need to finish the tunnel is decreasing as they continue to dig at 500 feet per month. The last question, how much time does it take to complete the tunnel? So again, we want to go down to 0 feet remaining, and if we go to 0 feet remaining, we see that it takes them 7 months on my x-axis here, 7 months. So this ordered pair would be 7, 0. That's my x-intercept. Remember, that means something about the story too. So this is kind of our two extremes in our story. This is the very beginning where they haven't started digging that 3,500 feet yet, and this is the very end where they have no distance left to complete their tunnel. They're done, and they've done a maximum of 7 months before they've finished. So again, all of the pieces of this graph tell something about our story. Our slope tells us that the distance is going down at 500 feet per month. This is where how much they start with, and this is when they finish their particular tunnel. All right, one more without a graph. You organize a garage sale. You have $30 at the beginning of the sale. We've got a garage sale, so we want to have some cash to give out, change and whatnot. Maybe it's all quarters and ones and fives. You earn an average of $20 per hour. You're doing a nice job with this yard sale. It must be some good stuff. We want to write an equation that represents the amount of money, y, that you have after X hours. So our y is going to stand for money, how much money we have in our cash box, and X is representing the time in hours as this garage sale goes on. So our slope, remember our slope is our rate. They talk about the same thing. If we're looking at a graph, it's our slope. If we're talking about a word problem, it's our rate. And our rate is $20 per hour. Remember, our rate is our y over our x. So we have amount of money y in dollars over our hours, so dollars per hour. We're doing $20 per hour, that's our rate. And our y-intercept, that's the starting point, that's the beginning of our story. We start the story with $30 in the cash box. So we're starting at 30. So again, I'm going to take my slope and my y-intercept, I'm going to plug them into this equation. Y equals 20, there's my rate, that's stuck to my x. We always find the rate stuck to the x, plus 30, this is where I start. So if I work with this equation at the beginning of this yard sale at hour 0, if I put a 0 in here, 20 plus 0, 20 times 0 is 0, plus 30, I have $30 at the start of my yard sale. That makes perfect sense. How much money do you have after 5 hours? Let's use this equation to see what happens in 5 hours. Remember, x is my hours, so I'm going to plug in 5 for my x. 20 times 5 is 100. 100 plus 30 gives me 130. So after 5 hours, assuming we're going at that nice steady rate of $20 per hour, I will have made $130. So even when there's a word problem and there's no graph, we can still think about the rate, and we can still think about the starting point to help us create an equation.